Good morning, my dear student. I am Rakesh Chaubey from Sunbeam Sun City. Jai Hind, you all, my dear. My dear, today's topic is simple microscope. Again, the optical instrument when the image is formed at infinity. If you remember, the last topic was uploaded by me for simple microscope when the image is at LDDV. And student has demanded, sir, you have not uploaded. Actually, I was uploaded, but unfortunately, this video was deleted. So let us see once again the topic on simple microscope for image at infinity. My dear, after doing this topic, I will tell you what is the main important way so that you can answer your questions very well in the exam. Am I clear? Magnification for which case is maximum, magnification for simple microscope which case is minimum. There is a numerical based on this. You should learn orally now, because now in the exam we are asking you the MCQ questions like objective questions. So this all will help you a lot. Now let's start for it. My dear, before I'll go to this topic, one small concept I wanted to share with you all. Small concept, and please try to understand that, and that you will keep in your mind. My dear, this image formed at infinity is also called normal adjustment. Please take care. This is again a CBSE can ask you a question. Do this derivation for the image in normal adjustment. And that is nothing but image at infinity. And for image formed at LDDV, I told you in my previous video, that is called image at near point. Near point for LDDV. And for infinity, it is normal adjustment. My dear, here a small thing I wanted to share concept. Sir, if the word is normal adjustment, you know why the word is given normal adjustment? My dear, this image, whenever the image is at infinity, the image when formed at infinity, my dear, we can see that image through a relaxed eye. Please, you see any book and refer the book. The image at infinity can be seen comfortably with the relaxed eye. Relaxed eye. Please. And that is why, my dear, it is called normal adjustment. Normal adjustment of eye. There is no strain in the eye. You can see the image at infinity with a relaxed eye. This is the idea, my dear, behind discussing about this. Because when the image is at least distance of distinct vision, the previous topic, my dear, no doubt the magnification is large in that case. I will show you that also. The magnification as compared to this, the magnification in LDDV is large. Please, I will show you at the end. No doubt if the magnification is large, my dear, and distance forming of image is least distance of distinct vision, that is 25 centimeter, and magnification is large, you can feel that to see large magnification, am I clear, when it will come to the eye, of course you have to give a strain, little bit strain occur. So magnification be large eye or distance be least distance pair. And here the image is at infinity, my dear. So you can feel yourself. सर आराम से कंफर्टेबली देख सकते हैं इसको, रिलैक्स आई से देख सकते हैं, नो डाउट. एंड मैग्निफिकेशन इज ऑल्सो स्मॉल. इट इज अ मिनिमम मैग्निफिकेशन ऑफ सिंपल माइक्रोस्कोप इन दिस केस. द लार्ज मैग्निफिकेशन ऑकर्ड इन लीस्ट डिस्टेंस ऑफ डिस्टिंक्ट विजन. So please take care of this part which I have shared with you all, and make sure that you are understanding. I am writing that also. Am I clear? I am writing that also, and then in the exam how you can do this shortcut method, I will show you that also. So here, my dear, a very important part which I shared with you is that when the image is obtained at least distance of distinct vision, that is at D, my dear, it produces, when it is weaved through eye, प्लीज आराम से इसको रीड कर सकते हो. इट प्रोड्यूस strain in the eye. It produces strain in eye. But image obtained at infinity can be seen or can be viewed through relaxed eye, my dear. और बड़ा सिंपल बात है सर. वाई सर एलडीडीवी पे मैग्निफिकेशन लार्ज होता है. मैग्निफिकेशन इज लार्ज कंपेयर टू इंफिनिटी. आज के बाद एमसीक्यू याद रखना है. सिंपल माइक्रोस्कोप वेयर द मैग्निफिकेशन इज लार्ज. फर्स्ट टाइम सिंपल देन कंपाउंड एंड ऑल. आई टेल यू एवरीवेयर वेयर द मैग्निफिकेशन इज लार्ज. सर मैग्निफिकेशन इज लार्ज इन द केस ऑफ एलडीडीवी. और मैग्निफिकेशन भी लार्ज है. And magnification is what? Angular magnification, that is nothing but a magnifying power. Magnifying power, that is a visual angle, that is beta, which is subtended at the eye. Visual angle by the image is large. Magnification large, visual angle subtended at the eye is large. Magnification is large, so visual angle subtended at the eye by the image, that is beta, will be large. और distance is least distance formation पे है. एलडीडी पे फॉर्म हो रहा है. ऑफकोर्स सर स्ट्रेन तो आएगा आई पर. और वही इमेज अगर इंफिनिटी पर हो, 1 मीटर पकड़ लो इंफिनिटी, 2f के बियॉन्ड सब इंफिनिटी है. यू कैन थिंक ओवर. जहां तक मैं रिलैक्स आई से इमेज को देख सकूं वो इंफिनिटी है. सो प्लीज ट्राई टू अंडरस्टैंड कि व्हाट इज द कंसेप्ट. एंड दिस इज व्हाई द इंफिनिटी केस इज कॉल्ड नॉर्मल एडजस्टमेंट. We can see the image of infinity through relaxed eye, my dear. उसका रीजन है सर मैग्निफिकेशन स्मॉल है एज कम्पेयर टू मैग्निफिकेशन एट एलडीडीवी एंड डिस्टेंस इज इंफिनिटी. सो यू कैन ईजिली सी दैट इमेज थ्रू योर रिलैक्स आई कंफर्टेबल. ओके, नाउ माय डियर लेट अस गो फॉर द टॉपिक ऑफ सिंपल माइक्रोस्कोप एट इंफिनिटी. नाउ यू ऑल नो दैट माय डियर इन माय फर्स्ट वीडियो ऑल्सो आई टोल्ड यू the angle subtended by image and angle subtended by object. प्लीज अब ये चीज तो पहले कंसेप्ट में लाओ. सर मैग्नीफाइंग पावर रेशियो है and it is a ratio of angle subtended by image and angle subtended by the object. Now let us begin with the object first. Now everybody know, my dear, we can see with a normal human eye the object can be placed up to least distance of distinct region, that is up to 25 centimeter. Chobe sir, there is no problem for object. It is clearly subtend a angle and we are denoting that angle alpha and without any lens. Try to understand object is moving. मैं पहले भी टॉपिक में बताया हूँ, अभी भी बता रहा हूँ. When object is, we are talking in the concept of this topic of this chapter. Please. Object के लिए there is no lens required. For image, I'm using a lens to magnify the image. And this is a simple microscope. My para word I have given in my first video, it is a magnifying glass. It magnifies the image of the object. So what I mean to say, my dear, please try to understand. Object के लिए please, for any topic you can see and you can feel it. Am I clear? And when I go for compound microscope, the object is objective convex lens and the eyepiece will be for image. Now when two lenses are used, I am using one lens for one objective and other lens for image. But here there is a one lens concept, my dear. So one lens concept for me, for this topic, my dear, my eye can be see a object clearly at least a distance of distinct region up to 25 centimeter, and there it subtend the visual angle of alpha. Visual angle of alpha is subtended by the object. For that, Chobe sir, please don't bring a lens in concept. Lens is for finding the image, magnifying image of that object. Please. So now, my dear, without drawing any lens, let us draw the object kept at least distant of distinct region, say here. Concept is simple, make it hard. Kyo, this is the same. And let the height of the object I have taken h. And here is my eye. A normal human eye can see the object up to this distance. That is, I am writing 25 centimeter. That is LDDV. Object at near point. What's wrong? That can be written ऑब्जेक्ट एट नियर पॉइंट, ऑब्जेक्ट एट LDDV, ऑब्जेक्ट एट D, सब लैंग्वेज है न्यूमेरिकल में, याद रखो, समझो. And now it is subtending an angle, my dear. Here it converges the light and can subtend an angle. Light ray converge and subtend an angle. This is a light ray coming from the object, subtend an angle, and that is alpha. Everybody. So what is alpha, sir? Alpha is a visual angle. Alpha is what? Alpha is the visual angle subtended by an object at the eye. Visual angle subtended by an object at the eye when it is capped at capital D. What is capital D? Least distance of distinct vision or near point. So nice. So can you find tan alpha from figure? Yes, sir. Tan alpha, simple, sir. Opposite side upon adjacent side. Opposite is your H and adjacent side is D. H by D. You can see my H by D. And if I use a Cartesian sign convention, it will be minus D because object is kept place and the light coming through this way. And distance measured from eye to the object. Eye itself acts as a lens, carrying a lens. So no problem. Eye to object, if I measure the distance, it will be minus D. No problem. No problem. You can substitute minus D. But my dear, you all know that when we write tan and sine and cos and all, we take magnitude of opposite side divided by magnitude of adjacent side. Please, if you see the definition of trigonometry says it is a length of perpendicular side divided by length of adjacent side or base side. So if I say length, I require only magnitude. I require only magnitude. So it will be H by D. I require only magnitude. So my H इसका magnitude है, D इसका magnitude है. So nothing doing, all concepts. चौबीस length भी लेते हो अगर definition से accordingly 10 का definition length of. And when we talk length, my dear, there is no concept of any Cartesian sign and all that much, because it's tan of alpha. So no issues about it. You can write directly H by D. And books has given directly H by D. That's right, because when we talk trigonometry, tangent of alpha, sine of alpha, sine of beta, cos of alpha, believe me, the definition is length of so and so to the length of so and so. So as soon as we say length, we take its magnitude of the sides. Okay, fine. So that also you can say, or if you wish minus, then also I'll show you at the end that minus will cancel each other. Look at it, they will become plus, and that's not an issue. So this is all about object, my dear. So what I thought about objects, or object के लिए कोई lens उसका जरूरत नहीं है. आप clearly you can see the object by keeping it at near point, that is at least distance of distinct vision, without any strain on the eye. So this is a power of accommodation also. Everybody know what is accommodation and power of accommodation. That is related. And you all know, everybody, that it is a my dear ciliary muscles which have this ability, my dear, to contract and to expand. Am I clear? So my dear, please try to understand. So we can see the things clearly at 25 centimeter. So for object observer it is fixed, and a visual angle of either object is alpha, that is also fixed. Now our aim is to find image at infinity. Now what should I do, my dear? I will place a lens here, you can see, because subtend the angle at the lens center and the same angle will be subtend at the eye. मैंने पहले भी सीखा है, आज भी बोलता हूँ, जो एंगल ऑप्टिकल सेंटर पे लेंस के सबटेंड करेगा, दैट एंगल इज सबटेंड एट दी आई. तो जहाँ पर ये अभी ऑब्जेक्ट का ये है, सपोज इफ आई ड्रॉ द लेंस हियर, माय डियर, विद द ऑप्टिकल सेंटर, सो आई कैन गो नाउ फॉर द इमेज. because I am introducing lens and I have to magnify this object. Am I clear? No doubt. I have to magnify this object, but simultaneously I don't want to give the strain in the eye. I want to see that image through my relaxed eye. I want to see the image with the normal adjustment, that is with the relaxed eye. So my aim is to get the image at infinity. Because I am knowing this is, say, sir, image at infinity rahega na, so we can see through a relaxed eye. Please. So now let's start, my dear, for the diagram for image formation at infinity. Ray diagram for image formation at infinity. Ray diagram for image formation at infinity by simple microscope. By simple microscope. Okay. Now what will be the diagram? Look at it, everybody. Say, my dear, here I have drawn lens. This is the optical axis, optic axis, and this is the optical center. Optical center, say this is O. And here is the principal axis. Now, my dear, I want image at infinity. Aram se jao. Do one thing. This is draw the ray parallel to this. The parallel ray. Of course, this parallel ray will pass through the principal focus. Like this. You all know this is a parallel ray. It is passing through the principal focus, Chaubisar. Here I can mark that. And now I will extend this ray here. You all can see, my dear. That is the formation of image, my dear. Similarly, I will do one thing more, my dear. I will take one more ray, because you all know, sir, to get image at least 2 rays required. So I took one more ray passing through the optical center like this. Passing through the optical center, and it will also extend it at the back like this, produce at the back to get the image. Now, my dear, here you all can see the image is at infinity. And I drawn the 2 ray one. This is a principal focus, parallel ray. And here now I can draw the object. You all can see now the object. But this object I have brought for the lens such a way that my image obtained at infinity. Please, this is a golden line I have given. I am not talking about the visual angle of this object, my dear, which is at least distance of distinct vision. That is my aim. मैं यहाँ तक object को आराम से देख रहा था. But here when I talk about this object, when you talk about this object, many students has a confusion of this. My dear, what I did, try to understand. I am showing you a kind of an experiment. Sir, you introduce as a lens, okay, and now you will see the object, ka image, okay. I start moving the lens like this, my dear. I start moving the lens from this point, because if I introduce the lens here, my dear, suppose if I introduce the lens here, now next step, and I start moving the lens on this side, I am sure as soon as this object comes to the principal focus of the lens, as soon as this object, which was at least distance with the normal eye, without lens, but as soon as I introduce the lens to get this image of this object, that's the experiment here. So please अब समझो कि method क्या है. Object ये था, यहाँ पे था. Naked eye is the object angle, visual angle, बच्चे. Naked eye, no lens introduction. And now I introduce the lens, and I start moving the lens, my dear. I adjusted the lens. I keep the object here only. Chalo. No issue. But I start moving the lens, my dear. As soon as the lens comes here, after, इसको बोलते हैं after adjusting lens, तो क्या आपको लगता है डिस्टेंस 25 रह गया? नहीं ना सर. So somewhere this object will be lie at the focus of this lens, because now the distance is this. So somewhere the object will be lie at the focus of this lens, and as soon as the object lie at the focus of the lens, the image, the parallel beam of light will enter, my dear, and of course, my dear, it will form the image at infinity. Everybody knows sir, focus पे अगर object होगा तो image is at infinity. So this is what is the case, बच्चे. So now you tell me, is this a real distance of the object or real angle subtended by the object? No sir. This is the angle subtended by the see, you can see here, this is the image. This is the angle subtended by the image, and it is beta. Because मैं पहले ही बता चुका, मैं लेंस के बिना ऑब्जेक्ट देख चुका हूं. प्लीज. एंड नाउ आई ब्रॉट द लेंस, आई स्टार्ट मूविंग द लेंस, आई स्टार्ट एडजस्टिंग, इसको किताबें बोलती हैं, आई स्टार्ट एडजस्टिंग द लेंस, एंड एज सून एज दिस ऑब्जेक्ट व्हिच वाज एट लीस्ट डिस्टेंस ऑफ डिस्टिंक्ट विजन फॉर naked eye without lens, now it comes to this object A, B, wow, same height H. It comes to the focus, and that I will take it as distance u. U for lens. Here I am writing UL. UL मतलब object distance for lens. Object distance from lens. And as soon as the object distance from lens comes to the focus, equal to focus, image become at infinity. And this object which is here at D, capital D, now it is magnified. No doubt, as compared to this stage, it is magnified, but image is obtained at infinity, and we can see through a relaxed eye. So nice concept, guys. So please don't confuse with this distance while substitution, my dear, in the formula, because here the angle is beta, my dear. This is image formation case by introducing lens. And this is the angle alpha by object without introducing lens when it is seen through a naked eye, that is normal human eye, up to capital D. And hence, my dear, any topic till compound microscope for the image formation either at LDDV or infinity, believe me, the object is placed at least distance of distinct region only. 4 केस में, simple microscope 2 cases, image at LDDV and image at infinity, compound microscope 2 cases, image at LDDV and image at infinity. अपने मन में डाल दो यार, object का visual angle is fixed by keeping the object at least distance of distinct region, that is 25 centimeter alpha. Please, ये जो मैंने object लाया है to get an image at infinity किया है, that is object distance from lens, and the visual angle which you are talking, that is the, my dear, through a naked eye without lens. I hope it is clear. So now, my dear, here, now use the concept, and you all know the magnifying power definition. So what is magnifying power? The magnifying power at infinity, small m. Here I am writing, if you believe, I can write infinity, m infinity is defined as the ratio of angle subtended by the at the eye, you can say at the eye, by the image formed at infinity to the कहाँ इमेज फॉर्म हुआ है? इन्फिनिटी पे. तो न्यूमरेटर में ऑलवेज देयर इज इन्फिनिटी एंड देन डिनोमिनेटर ऑब्जेक्ट. सो इमेज एट इन्फिनिटी टू द एंगल सबटेंडेड by an object at the eye, and at the eye मतलब naked eye, without lens दोस्त please, without lens I am looking the object. And therefore my dear एक concept clear होना चाहिए कि सर अब वो समझा मेरे को कि अल्फा इधर बनता ही नहीं है, because I introduce the lens, now I am magnifying this object by with the help of image, which will, with the help of lens it will magnify the image of this object. This lens will do that, and that is called magnifying glass, and that's a simple microscope. तो सर इसको जब आप मैग्नीफाई करने के लिए ये लेंस को मूव किए सर, और एक स्टेज ऐसा आया कि माय डियर दिस ऑब्जेक्ट जो नेकेड आई के लिए एलडीडीवी पे था, कितना अच्छा बता दिया और प्लीज समझो, वो सर इस ऑब्जेक्ट के इस लेंस के फोकल लेंथ पे आ गया, फोकल पॉइंट पे आ गया, फोकस पे आ गया, और जैसे ही ऑब्जेक्ट उसके फोकस पे आ गया माय डियर इमेज इज एट इंफिनिटी, मेरा काम हो गया. दिस इज द विजुअल एंगल फॉर्म बाय द इमेज एट द ऑप्टिकल सेंटर एंड हेंस एट द आई. Here also I can draw the angle. What's wrong? And it is same angle subtended. Okay, subtended by an object at the eye, capped at, ये line important है my dear, capped at LDDV, that is D or near. ये fixed है बेटा, all four cases I said, except telescope because their object will be at infinity, distant object. Concept को रखो so that magify don't mark. Okay, so now substitute the values here. I am rubbing this side, so now substitute the value, and 10 as soon as we are substituting 10, see my dear, that's what I have given the all concepts. Sir, you are using tan, and tans are tangent or sine or cosine are defined in terms of magnitude my dear. Please, that is a trigonometry, they define in terms of magnitude my dear. You can see their definition, it is given. I hope everybody know also. Length of so and so side divided by length of so and so side. So if it is length of sir, no question worried about the direction, this, that. Am I clear? Cartesian sign. That is one thing. And if you are using also, that also I will show you in shortcut. If you use that also, my everything is applicable, nothing problem. You can take minus here because it is minus, and there also minus. Ultimately answer will come in plus. So I will draw in this diagram my dear, which is for object. This diagram should be in your paper. ये diagram होना चाहिए for object separately. That is for eye. Angle subtended at the eye. So my dear, now let's go for the next solving of this. So magnifying power at infinity will be nothing but my dear beta divided by alpha, that is equal to 10 beta divided by 10 alpha. कहाँ से मिला? By definition. I have written in my definition, it is a ratio of angle subtended by the image subtend angle and visual angle beta to the angle subtended by the object. Visual angle subtended by the object is alpha. So now my dear, here I can go for this. This is 10 beta upon 10 alpha is your magnifying power at infinity, that is equal to 10 beta. You can see the diagram carefully. 10 beta, opposite is AB and adjacent is OB. Divide by this is 10 alpha, here I have already done here. This is AB divided by EB. You can put this as I as E, EB. So now my dear, here this is nothing but BE or EE divided by OB, EB divided by OB, because AB and AB cancel, H and H cancel, H and H cancel from both the side, that is AB, AB. So it is EB by OB. EB is what my dear, you can see U. I hope it is clear. Again it is 10 sir, no, not worry about their sign, and if you wanted to put also, no problem. So here it is given as how much, this U is how much my dear, D, you can see. Am I clear? EB is D and OB is, my dear, you can take it as, say here it is minus D, so here it is minus F, answer will be D by F. Why minus D? Because it is, object is viewed this way and the light converges to the eye this way. So the distance of the object and the converging, the distance measured and the light ray going, I am applying Cartesian, my dear. I told you that I can apply Cartesian, so the answer will be D by F. I hope it is clear. You can do the same answer like this also. Suppose here I have taken UE. Suppose here I have taken U only. This is U. UL. That is object distance from lens. Suppose. I hope it is clear. So now, my dear, what will be happen here? Look at it. This will be UL. You all can see the UL value, and UL is negative if I apply the Cartesian, because Chaube sir, the light is going this way and the distance is measured this way. So of course Chaube sir, UL to आपको negative लेना पड़ेगा. Okay. So if I use the UL as negative, my dear, what's happened? Look at it. I will show you what is happening. 1 upon V minus 1 upon U is equal to 1 upon F. Since image is obtained at infinity, U is equal to UL. U is equal to UL, you can see. But which UL? Sir, it is minus UL. See, I am showing many way. Answer will be what the answer will be. And F is F only. So this is nothing but 1 by infinity minus 1 by minus UL is equal to 1 by F. Sir, UL is equal to F. So everybody, my dear, no problem if I substitute here minus and get the answer. Minus, and this is also in minus by Cartesian sign conventions. Am I clear? और मेरा एक बहुत बेहतरीन चीज I have told you all. Better is that. So here I am taking this as F because that U is become F. UL is now F. That is the focus. Everybody know. And the best is, so this is what I have shown you all, बच्चे. कि सर चौबे सर आप कोई भी method से करो. You adopt any method. You adopt any method, my dear. Either by using Cartesian sign convention or either by tangent concepts or length concepts. My dear, your answer will become at the end in positive only. Because if you take the Cartesian, minus and minus will cancel and it comes in positive. Or if you apply tangent concepts, it is again in positive. So here, my dear, that's all I wanted to tell you. So this is 10 beta by 10 alpha. So this is m infinity is equal to 10 beta. 10 beta you can see from the diagram. Chaube sir, it is AB divided by OB, and tan alpha is nothing but, my dear, this is AB divided by EB. This is nothing but, Chaube sir, AB divided by OB. If I write, this is H by F, this is H by D, and answer will be D by F. I hope it is clear. Am I clear? Because ultimately now this is the magnifying power at infinity. And it is equal to tangent. They are equal to tangent, my dear. So sir, मेरे को कुछ टेंशन नहीं है साइन को भी लेकर. और आपको ये भी मालूम होगा कि we are expressing magnification in terms of mod also. We say plus sign, so we say virtually red. When we say minus sign, we say real inverted and all that. So that is the related magnification, बच्चे. So this is what I wanted to convey you all. The answer for infinity is D by F. D by F. So I hope you all clear the concept very well. Am I clear? अब यहाँ पे तुम यहाँ माइनस भी डाल सकते हो. सर यहाँ माइनस डाला, कार्टेशियन यूज करना है तुमको, करो. माइनस यहाँ डाला तो यहाँ भी माइनस होगा, बिकॉज ये भी डिस्टेंस जो मेजर हो रहा है वो आई से ऑब्जेक्ट हो रहा है. आई से ऑब्जेक्ट हो रहा है. आई फिक्स्ड है. जो फिक्स होता है वहाँ से डिस्टेंस मेजर्ड होता है. ऑब्जेक्ट वेरिएबल है. सो आई से ऑब्जेक्ट मेजर हो रहा है, मतलब डिस्टेंस ऐसे मेजर हो रहा है. सो आपको चौबे सर ये भी माइनस होगा, तो अगर माइनस माइनस डालना चाहते हो तो भी आंसर बेटा यहाँ माइनस डालते हो, यहाँ माइनस डालते हो तो भी आंसर प्लस डी बाई एफ. सो दोनों वे से आप देख सकते हो, आपको मैंने सारा चीज़ बता दिया है. दिस इज वॉट इज द कंसेप्ट. नाउ माय डियर, लेट्स गो टू comparison. Now I obtained the magnifying power at LDDV, and the answer for magnifying power at LDDV is 1 plus d by f, and the magnifying power obtained at infinity is 24 d by f for simple microscope. तो पहला क्वेश्चन है, where the magnification is maximum. The first answer is magnification is maximum at LDDV, that is image formed at LDDV, that is capital D पे जब image मिलता है तो, when image formed at LDDV magnification is maximum. Look at infinity पे d by f है, खाली infinity पे d by f है, यहाँ 1 plus d by f है. सर मैग्निफिकेशन इतना ज़्यादा होगा LDDV पे, अब आ गया और टाइम वेयर आई शुड एक्सप्लेन यू. सर if magnification is so large, it is maximum at LDDV, so the visual angle will subtend at the LDDV will also large, and if visual angle is subtend large, so at the eye sir of course वो angle जब large हो गया तो angle को देखने में my dear it will give a strain in the eye. Distance भी कम है, angle large है, you can see कोई बहुत लंबी चीज़ आए नाक पे आ जाता है, the angle subtended will be difficult to strain to the eye. But the same thing can be observed, the same image can be easily viewed through a relaxed eye when it is at infinity. Normal thinking you can have this. So maximum magnification is occurred at LDDV, my dear. And second, magnification is minimum when image is formed at infinity. और कितने से ये मिनिमम है? 1 less. It is its magnification is 1 less than 1 less, एक से कम. This is 1 plus d by f and it is just d by f. So its magnification is 1 less than that of magnification at LDDV. One less than the magnification at LDDV. So please take care, my dear. This is infinity पे magnification is 1 less, and since the magnification is less, it can be easily viewed through a eye, through a relaxed eye, because visual angle will also be less by the image at infinity as compared to LDDV. So this is all from my side, my dear, on the simple microscope. Please take care. This is an objective question, that where the magnification is large, where the magnification is minimum. Am I clear? Or if the numerical given, the simple microscope was observed and the magnification is minimum, so immediately think that you have to apply the formula d by f. It is talking about infinity. And if say the magnification is large and the image is obtained at so and so, so immediately think that you have to apply formula 1 plus d by f. So that's all from my side, bacho. Thank you all and Jai Hind.